Hi, my name is Jordan Stevens, and I'm going to be explaining our homework 1 for Engineering 460 Data Simulation. I'm going to start off, and I'm going to group with Danica Dvorak. I'm going to start off with our first problem, problem 1.5.1. This is to do the integral of exponential to the negative x squared times the absolute value of cosine of x. Now, after first looking at this equation, we can see that it very closely resembles, at least the exponential part of it, very closely resembles the normal function. So we want to extract the normal function from this integral because we know as the definite integral approaches this, it's going to have a value of 1. So what we need to do is we need to do a substitution. Our substitution will involve x over square root of 2. We know that it is x over square root of 2 because if you plug this into this function right here, you're going to get this top part. And we want to make sure that we keep track of this dz, or the Jacobian right here. This will be put at the front of the integral, or extracted out of the integral once we take it. So now that we have that part right here, we also have to put it into the cosine part because we're doing a substitution for all the x values. So this is going to be x over the square root of 2, same as this one. And we also put this square root of 2 pi as another one right here. But since this is just an easy part to add in, it's pretty easy to add in. You have to multiply the outside and the inside by the square root of 2 pi. So this is going to be moved to the outside. And our final thing that we're going to do, since we're going to be extracting this and we're going to be putting this out in the front, is going to be this formula right here for the expected value. We know that we are going to vary based on a normal distribution because that is what we extracted from the integral. After doing those numbers, we get this right here, this equation right here. And to find the upper and lower intervals, all we got to do is find the standard deviation, put it in there. For our second problem, that's a little harder of a problem. It's the same exact process, except we have an x and a y variable. We know that both of these will be very closely resemble a normal distribution. So what we're going to do is we're going to do another substitution for the y minus 1, and we know that the Jacobian of that is just 1, so that's pretty easy for us because we don't have to add anything else out in the front because it's just going to be multiplied by 1. Since we're doing it as a double integral and there's going to be 2 of the uniform distributions used, we have 2 of these 1 over square root of 2 pi's, in which when you multiply them out in the front, it's just 2 pi. And then the rest of the equation right here, that could be easily put into the exponential. It's this expected value, and then we randomly generate x and randomly generate y to find the solution. And that is showed right here, where we can see the distribution. Now I used these integrate functions to make sure that it was the right answer. This one was pretty easy, just doing it in MATLAB. This one was relatively hard because it doesn't like absolute values. The integral function doesn't. So what I did is I made sure to go to Wolfram Alpha, put the integrate function in here just to check my answer, and we see that it is very close.